We're live. We're live. Live from the basement of my home in the Northern Hemisphere, the West Coastish of Canada. Look at the camera. Look at the camera. Look at the camera. All right. And we got to wait for the people to swarm in because we're really only scheduled for 9 a.m. Pacific time, and it is 8:58, and we would hate people to miss the first two luscious minutes. So what do we do for that first 2 minutes that nobody's here for? I could drink my coffee. I'll drink my coffee. And the notifications got to come in and all that sort of stuff. And I know everybody wants to see this integration because today is a good day to integrate. Oh, if you show up, say hi in the chat because that'll make me notice and I'll say something to you. I guess I could just go over here and let's do some doodling. Excuse me. Let's make sure this works. Let's kind of test things out here. So there's a smiley face. Today is a good day to integrate. It's great to integrate. And let's give this guy some legs. And what does this look like? What is this? There you go. So now you can see. Now you can see what a great day it is to integrate. And we're going to start right away. It's actually not 9 o'clock yet. Wow. I'm sitting here just talking to myself for a minute or two. This is not, and I can't really, I guess I could edit it out, but I can't really do that. So now whoever clicks on this is going to have to skip ahead. Maybe I could put something in the, what do you call it? In the thing down at the bottom there so that timestamp. I could timestamp it. That's what I could do. So that somebody watches this later, they don't have to listen to me just talking about what a great day it is to integrate. Is it 9 o'clock yet? It's 9 o'clock. It's 9 o'clock. I'm starting. If you're late, you're late. Just don't disturb people coming in. Get your seats, everybody. Okay. So I decided this time to hang on here. Where's my? I'm just gonna thicken that a little bit. I decided this time to not bite off so much and just do a fairly straightforward integral. And so that's what I'm going to do. Oh, look at that. Look at that. Now my thing says it's 9 o'clock. My phone says it's 9 o'clock. So we're going to go with that fairly straightforward integral. So hang on here. Okay. Too many things happening here. So let's move this aside. Let's move this aside. We'll have to look at it later. All right. So what do we got here? We have got a arcsine, what is it? Sine to the -1 of x. And it's the same as the, arcsine is another term for it. Okay, arcsine of x. And then we don't have this confusing -1 up here, which in this context means the inverse function, but in another context means the reciprocal, which is also a form of inverse function. So it's a little bit of sloppy nomenclature here. So let's go ahead. I'm just gonna keep on using this term. So what do we got here? So let's draw a function, and the domain is between 1 and -1 of the arcsine function, because otherwise, oh, that's about to die. Yeah, quiet. Okay. The domain is between -1 and +1. Okay, because we have to restrict the domain to keep it being a function. Okay, otherwise, it's like the square root function. Okay, so there is sort of, and we're interested in. So this is 1. Okay, and so this is, what do we got here? There's, call that y, call that x, and this beautiful work of art is the arcsine of x. Okay, and so this point right here, okay, that's the arcsine of 1, so it's pi by 2. And I've purposely chosen limits of integration that are going to make this really easy and pretty, but we may get into generalizing this and even generalizing the generalization a little bit. But what we're looking at here is the integral between 0 and 1 of the arcsine of x dx. Okay, so that is this lovely piece of work right here. Okay, we're looking for that area between 0 and 1. Oh, somebody's watching. Always radians. And then he says answered. Okay, yeah, you know, that's good question. Yeah, radians. You could probably, by the time, when you're, I don't think I've ever seen integration of trig functions done in anything other than radians. And it would be interesting to try using degrees and then seeing what goes wrong, and then just in the exercise of doing that, it might help sort of justify why radians are good and degrees, while they can be more intuitive, don't always make the mathematics easier. You want to be an actuary. Awesome. That's something that you can be when you where you could use this in the real world or whatever. So okay, so let's go do this. Okay, so yeah, again, I mean, I've chosen, there's all sorts of examples of doing this kind of thing, but I've chosen one that's really easy. Okay, straightforward. First of all, what I want you to notice is that for this technique, this is a one-to-one function, which means that it has an inverse. Okay, and that's what makes this work, what we're going to do here. And so the first thing that we're going to do is we're going to find the area of this rectangle right here. And don't all speak at once. Okay, what is the area of that rectangle? Let's hear you. You're there. I can hear you breathing. You can't sit in the back of the class here because there is no back. And there's no class. I've done this before where I've done something live. I'm teaching something live and there's 3 students. It's just a small thing. And it's you can't sit at the back of the class. Come on, guys or girls, gals, folks. Yeah, it's pi by 2. Thank you, wannabe actuary 01. Yeah, pi by 2. Let's go there. Sure, because you got this length right here is pi by 2, and this width is just 1. So let's draw that. So we got pi by 2, and that's 1. And so yeah, so that thing here is pi by 2. And I think I better go down to something different now. All right. So now let's change this and let's make it a little bit like it is in a lot bit smaller, so it's doable. Okay, gang. Now, rather than directly integrate this thatched bit here, I'm going to ask you, what's the area of this? Because this is a lot easier to work out the area of this bit here that I'm just shading now. What is that area? And so that's the next question, gang. Let's make sure that somebody hasn't answered it already. Okay. Yeah. Okay. Yeah, y'all got it. Yeah, pi by 2 times 1. Pi by 2, pi times. Oh, hang on. It's an emoji somebody's got there. Okay. So, okay, area of the green bit, or the part that I just colored, because I don't know if everybody can see color. So what do we do with that? Gaxby, you think that area might be 1? Is that what you're saying? And you got 1 question mark, because yeah, it might be 1, but how can we know? How can we know what it is? It ends up not. How do we know if it's 1? Where do you get that from? Let's go and let's do this. And I'm gonna go back to the black here. So this bit right here, okay, I mean, that is, I'll draw it over here. Okay, I'm going to invert this, okay, where this is 1 and this is pi by 2, okay, and this other function here is the sine function. Okay, I mean, I picked it this way so that it would work this way. So we've got a function that is super duper easy to integrate. I figure out how to do this by integrating the sine function from 0 to pi by 2. Yeah, exactly. You got it, and that's where you come from. So yeah. So let's just do that here. So we've got cosine. Sorry, I'm getting ahead of myself. The sine of x dx. So it's a different function here, because now I'm still using x. You might see somebody else do this where they integrate across y. Okay, but I'm not going to do that. I figure let's just flip the function and do what we're familiar with. Okay, and so that's between that's between 0 and pi by 2, and that equals the negative cosine of x between pi by 2 and 0. And let's scroll that now. Yes, I like drawing with Miro. So what do we got here? We've got the negative cosine of pi by 2 minus the negative cosine of 0. And what does that give us? Cosine of pi by 2 is 0. So it's negative 0. Minus cosine of 0 is 1. So it's minus 1. And so that's a lot of work to just end up with 1, which is probably what you might have even done that in your head. So yeah. So there's this. So that is 1. And so that means that this, let's go back to green, that bit here is 1. Okay. So what's our final thing? We want this black area. So what is it? It's pi by 2 minus the green bit minus 1, and Bob's your uncle. And we could stop there, or we could go on and go, hey, okay, what do we got here? How can we generalize this and make this into something that doesn't just work for this particular function? And that's kind of where I think we need to go here. There we go. Okay, so you all happy with this? I mean, really, we've solved the puzzle in the thumbnail, but let's take this a step further. Okay, so let's roll, gang. Okay, so I'm gonna do a little scrolling. And we're going to do this one again. And we're going to generalize it a little bit, and then we'll generalize it a little bit more if we think that that's going to be useful to us. So here we go. So here is, okay, so that's the arcsine of x. And this time, we're going to go from B to A. So we're not going to get a pretty answer this time, a pretty solution, but we're going to get one that's more general. Okay, so what do you got here? So this is arc sine of B, and that's the arc sine of A. Okay, are we good with that? So now we'll take what we did generally, and the first thing we're going to do is, let's do this rectangle here. And before I do that, I guess I should say what we're trying to work out. So we're trying to work out between B and A, the arc sine of x. So what we're trying to work out is there's that area here, okay? And now we're going to generalize. So what's the green rectangle? So what's this one right here? What do we got? Green rectangle, guys. This is the audience participation. B arcsine B. Right on, Gabixy. Awesome. Let's write that down. Okay, so that's yeah. So that's B arcsine of B. All right, and then let's we'll make it red. So red rectangle. Spit it out. You don't need to put up your hands. Red, or I guess that's orange. Orange rectangle. Maybe I should change my the name of my channel here to red rectangle, orange rectangle. How does that sound? Or should I change it from Math Atom to Hat Atom, because like hat is part of my brand. I start to feel bad if I make a video without a hat. I had somebody on Twitch call me out on that. They said, "Where's your hat?" Okay, A arcsine A. Thank you, wannabe actuary. Yes, you win a brand new car. All right, so yeah, so that's A arcsine of A. Okay, and then now we need to find a different. Well, I guess I'll just use green for this, eh? Okay, so we'll draw it like that. So what is this? This is going to be a little trickier to write down. So I can't see it going nice and easy into the comments, right? But it's the same as we did with the sine, hey? So that's going to be the sine of x dx. And what do we got here? Limits of integration now are arcsine of B and arcsine of A. Okay, that's kind of funny. But again, I'm somebody else is going to come along and say I'm being a bit of a jerk here because I'm integrating across X, but it's the same numbers. It's the same numbers, but technically we're integrating across Y. Okay. So yeah, so we're going to take this. Let's finish it up here. B arcsine B minus A arcsine A. That's really messy. Minus this thing. Okay. The integral between arcsine of B and arcsine of A of sine X dx. Okay, so now we've generalized the arcsine function. Okay, clear as mud, clear as something. Okay. Okay, final step. Actually, let's take a look at that. Let's take a look at that on Desmos here. Hang on, I'll show you what I'm doing here. I gotta share that. Hang on, how do I do this? Share it on Desmos. Okay, I gotta change my share. Stop screen. It's just big me. Okay, hang on, it'll get better. Share screen, and Chrome tab, and there's Desmos. Okay, there we go. There's Desmos. Okay, now, so here's your generalization, and I'm assuming that you can see my my mouse here. Okay, so here's our main. There's our main function. F of x is the arcsine of x, and then I've chosen these limits of integration. Let's set it to what we had before. Okay, so let's set that between 0 and 1. Okay, and so now we've got, so this is, this is down here, that's that 0, and then we're going between there and up here. And you might recognize this as pi by 2 because that's our original rectangle. And then I should set this up so I can write on this while I'm doing this. Okay, and then there's our inverse function, which I haven't written it as an inverse function, but in this case, it happens to be the inverse function. Okay, and here's the generalization of what I'm going to, I'm going to cut and paste that, and I'm going to put that on here. Maybe that's what I should do here so we can all look at it. But the fun part is like you can do this at home and just play around with this. I did this just to check to be sure that my math was right, because it's easy to make mistakes. And when I first did this, I had A minus B. I was wondering what I was doing wrong. So it really made me have to focus and get this right. But there's a thing there on Desmos where you can see how that works. And you know what? I'm even going to, I'm going to share this with you here. Hang on. I got to log in first. Just a second. La 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 la. Okay. So I'm going to call that the arcsine thingy. I don't know how much of this you can see. I'm going to find that out soon. Okay, and then see, now I can share it, and I'm going to post a link to that. Copy, and I will post it right down here in StreamYard. So you guys can actually go and you can check that out. Okay. Oh, you're given the formula a long time ago. Yeah, because we can write that down as, again, I haven't totally generalized this. Okay, we're still just doing arcsine, but now let's take a look at this, and I'm going to go back to the what do you call it? Oh yeah, I got to make sure I'm sharing. I bounce around from tab to tab here. Stop share screen. I'm going to share. Let's go. So let's go back to let's go back to sharing the window, Chrome tab. Hang on, Arcsin. There we go. Okay. Okay. And so what are we looking at here? We're looking at generally I mean, what's our general thing here? So we've got some function. Okay, so we've got some function between b and a. Okay, dx. And here's the thing. Okay, this works with a one-to-one function. Okay, we haven't generalized it so that it's works for non-one-to-one functions, but I mean, why not? I mean, we could see what happens when we go there, but I'm not going to do that at this time. That would be fun to take home and try that out. Okay, so what do we got here? We've got b times f of b, okay, minus a times f of a. So now we're just generalizing this for anything. Okay, and then minus, and let's just slide that over a bit. Okay, and then we'll do the integral between. Okay, so now we've got f to the minus 1 of x, okay, dx, between the original function evaluated at b and the original function evaluated at a. And all I've done here now is I've gone, okay, how can we say this for any function? And what is it about the function that makes this work? Well, in this case, it's a one-to-one function. Hey, so we have this works with a one-to-one function. How we could apply this to a non-one-to-one function, that would be something fun to think about. That's as far as I want to go with this, but I'm also going to post a link eventually. I'll post it in the description or in a pinned comment down there. There's a young fellow that wrote a paper using this technique as a way of visualizing the integration by parts. And you'll notice if you've seen my last, I did a video where I used it before, and the whole point was, I'm not using integration by parts, and it's because these ideas are linked. And I'm not making any sense here, so I'm gonna post that eventually. You guys can check that out, and maybe we can even look at that in detail on another live stream or something like that. That's all I've got to say about this. So, in my opinion, this went a whole lot better than the last one. I don't know if you saw the last one, but I was just all over the map. But here I had a specific thing to cover, and so I'm so happy. Any comments about that? Oh, you know what else I'm going to post? Before I go, I'm going to do this. I'm going to post, and this will only be available for a little while, okay? But so that you guys can actually go and take a look at, this is on myro.com. You guys can actually go and take a look at the thing, okay? But you can also write to it. So I'm not going to let that last long, because if people mess with it, then eventually it's not going to be worth anything. But you can take a look at that if you like. Okay, I'm going to roll. I've been talking real fast. I hope that clarified some things for you. Want to be Actuary 01? Yeah, you like that. You made that clearer for you. Do you have any questions about this before we sign off and we call it a day? Just say yes or no, because I hate hanging up on you while I still see the eyeball looking at me. Or you say bye or something, or knock 3 times. No, awesome. Thank you, Want to be Actuary. You rock. Okay, so now yes, Gabaxy says yes. You have a question? Yes, Gabaxy? Bye. Yeah, bye, Want to be Actuary. Now there's more people showing up. So you can tell that the live stream is over when I say Bob's your uncle. and I make some reference to llamas, which I've just done. So I'm going to roll. Thank you so much. And you can still put questions and things like that in the comments and make your commentary. And it's been awesome. So thank you so much. I'm going to end the broadcast. I think you'll still be able to chat for a while. I'm not sure how that works. So and we'll talk to you guys. We'll talk to you all next time. Okay. Bye-bye.